Well, hello, hello, hello. I am live tonight. It's good to see all you on here. And I am going to kick this off in just a second. Let me get everything set up here. All right. There we go. Got that. Okie dokie. So here we go. Let me pin this on here and we're good. Okay, folks, it's Phil Zito, and I'm here live streaming from BuildingAutomationMonthly.com's weekly live stream. And this is my way to continue to give back to those of you in the community and continue to help us reach our goal of 20,000 new building automation technicians by the year 2025. You know, I was doing some math the other day, and I double check my math here. But if we did 20,000 technicians, and the average technician earns about $40,000, we would bring $800 million into the economy by 2025, into the global economy. That's pretty freaking crazy. So, that is my goal with BuildingAutomationMonthly.com, is to teach you building automation fundamentals and other things related to smart buildings. Thank you for joining today, and feel free to introduce yourself as you are coming into the live stream. So, all right, I see that we just got a question from Rob coming into my notifications here. And Rob, if you are in the live stream, let me know, and I'll address it in the live stream. But with that being said, let me go through what we're going to cover today. So the first thing I'm going to do is I am going to talk about what's been going on at BuildingAutomationMonthly.com this week, what is new, what is happening, and what you can expect. Then we're going to go into a technical teaching where I am going to be covering Pid Loops. But this time, it's not audio, it's not a blog article, it is actual video where I'm going to be going through and covering that. And then I am going to go into question and answer. And one of the questions I will answer here is Rob's question right down below the live stream. And then I am going to share with y'all a network fundamentals course that is absolutely kick-ass that I found that is going to be freaking amazing. And to make it even more amazing, it's free. So with that, give me 2 seconds. I have a 8-year-old standing outside my door. What's up, Trevor? Can you get some food? I told you to eat before you went to bed. Just go get yourself a bagel and then go to bed. Yes, this is indeed live. And I have little children who are hungry. All right. With that being said, let's move into what's happening at BuildingAutomationMonthly.com. And for those of you watching, let me know where you're from. Let me know who's watching. I always like to know who's in attendance. That way I can make sure that I am covering what you want to learn. So BuildingAutomationMonthly.com. This week, we kicked off the System Integration Series, System Integration 101. Now, I'll admit, I've been pretty freaking lazy. Folks have been asking me about this for the better part of a year and a half now. And then probably 50% of the survey results said, hey, System Integration Survey, or System Integration 101, that's what we want. So that's what you're going to get. 8 weeks of system integration, all streaming to you via the podcast and the blog articles, and quite possibly in these live streams as well. In addition to that, I've kicked off the Learn series. And the Learn series, I'm going to be building out essentially a building automation technician course using this Learn series. And that's going to be on Wednesdays, the blog articles, and Fridays, the podcasts. And then on top of that, the book is moving along. I'm still writing the book. It's still slated to come out the second week of December. And that's moving along great. So with that being said, I see I got one comment here. I'm going to take a look-see. Awesome. Rob, I love Toronto. there is a great all-you-can-eat Mexican food restaurant by the airport, by Pearson International. And that's probably responsible for a good 5-10 pounds that I've put on over the years. All-you-can-eat beef fajitas, awesomeness. So, it's good to see you here, Rob. And let's, without further ado, move into tonight's teaching. But before I do that, I just want to let you all know, you will be noticing the podcast will be sounding a little different. I've been starting to get a kind of feel for how I like to do them. It's all starting to come together. I've actually got a halfway decent podcast mic. As you can see, ridiculously oversized podcast mic. And also, something I'm super duper ridiculously excited about is I realized that my wife's camera right here shoots 1080p video. So I was planning on teaching on my whiteboard back here, and hopefully you guys don't get dizzy when I do this. But I was planning on teaching on my whiteboard back there. And I was planning on doing that once I got a video camera. But I've got a video camera now. So now that I've got that, I can actually start doing that. And that's going to make things even more awesome because I can start doing YouTube videos. Alrighty, so tonight we are going to cover Pid Loops. And I'm going to go into a teaching on that right now. But before I do that, any questions? Feel free to let me know as I bring all this stuff up here. Oop, here we go. And let me bring this over here. So for those of you who have never been on a live stream before, the streaming software itself tends to lag by about 30 seconds. So what that means is that what you're seeing, I'm actually doing 30 seconds ago. Now, that's good and that's bad. It's good in that we get a live stream. It's bad in that sometimes it takes me a little bit to respond. The responses are sometimes delayed. So I'm going to start showing you Pid Loops. And we're going to go through a quick teaching on this. But before I do that, everyone in the audience, kind of what is your comfort level with Pid Loops? How do you feel about them on a scale of 1 to 10? What would you say? And while you are answering that, I will go here and start doing this teaching. All right. So, you all are seeing the MS Paint that I'm about to display. I'm going to write, are you seeing this? Awesome. Mike, that's great to see that you are very comfortable. Then hopefully this will just be a refresher for you. And feel free to add into the comments anything you would like to clarify as I go through this teaching. Definitely want it to be interactive. So let's erase this out. All right, PID loops. Okay, proportional integral derivative. Derivative. I can never spell late at night. Or PID. Now, for those of you in the controls world, really, we're talking about PI loops because very rarely will you use derivative. So we're going to talk through this, and my goal is within 10 minutes to teach you a PID loop. So let's see if we can do that. So the first thing we need to understand is, what is a PID loop used for? Well, if you were to look at a controller, so here's your typical controller, right? And you've got an input coming from a temperature sensor. And this temperature sensor has an output going to a valve. Okay? And let's say that this is an analog output and this is an analog input, right? This temperature sensor here is coming into the controller, and inside the controller it's got a set point, right? And this would be called a logical point, oftentimes called an analog value. All right, so that analog input and that set point for that temperature are going to come into your PID loop. And then out of your PID loop is going to come the output to this analog output. So you all with me so far? The analog input comes into the PID loop right here. Now sometimes there's a difference between temperature and set point. Right? So temperature and set point, there's a difference between the two. And that difference is known as the error. Okay? So now we have our first point in the PID loop, and that is our error. Okay, so right here, if we're to unpack our PID loop, we've got the error coming into it. Now, right off the bat, if we have error, we're going to have a big fat 0 coming out of our PID loop because it's not telling it what to do with that error. This is where the proportional band comes into play. Proportional means in proportion to. So if you were to say, what's a good example of proportional, right? So if we're going to say, we've got an error. Yeah, you know what? I'll use a span block. That's a good example of proportion. Where 0 to 10 equals 0 to 100. You've got a span. So from that 0 to 10 volt input, that may mean a 0 to 10 volt or 0 to 100% signal. Well, proportional is the same thing. So you've got proportion right here. And we're going to do our first thing. Error times proportional band equals output. That's pure P. So that error times the proportional band is going to equal our output. So let's say we have a proportional band of 10 and our error is 2, right? 74 minus 72, that's 2. So our error of 2, then 2 times 10 equals 20, right? So our output of our PID loop would be 20. So that is the proportional piece. So I want you to keep that kind of in the back of your mind real quick. And we're going to move over to integral. Now integral is the time piece. So what happens is you very well could get stuck in a scenario where you hit just the right output and your error stays the same and your prop band, then you stay at 20 because that output is never going to increase. And that's where we have the time variable here. So I'm going to just check, make sure everyone's tracking. Make sure we don't have any questions so far. All right. So you got this time band here. Okay, and as this time is introduced, what's going to happen is you have what's called your I factor. And each time this loop runs, you're going to add more I. So basically your I factor is I plus I times the loop. Wait. Yep. No. Yes. Maybe. No. Here we go. I'm trying to remember math here. Basically what I'm saying is the sum of I. Yep, that's what I meant to say. I know it's not E, but I can't draw the sum symbol. So forgive me. I'm not a mathematician. So I plus the sum of I. And basically what that's saying is each time this loop runs, you're going to add one I, right? Now what does that mean? So let's use some numbers here. You've got 0.1. The first time this loop runs, I is equal to 0. So the loop is going to run, and now it's going to be I is equal to 0.1. Well, each time I runs, I is equal to 0.2, I is equal to 0.3, and it keeps ticking up. And then what's going to happen based on your I is this is going to go 20.1, 20.2, 20.3. You get the point. It's going to increase. And so what you're doing is you're saying, all right, I still haven't hit set point. Add a little more, add a little more, and that output is going to increase because you haven't hit set point yet. So I'm going to clear this off real quick. All right. So we've got our PID loop. We've got our error coming in here. And our error is temp minus set point, or input minus set point technically. I'm just using temp. We've got our prop band, and we've got our I. And that's coming in here, and this gives us our output. Now, as we remember, the equation is error times P plus I plus... Okay, that's not even the sum symbol either. The sum of I. Gosh, why can I not draw the sum symbol to save my life? Output. Okay. So that's our equation. And then when we're tuning a loop, the first thing we're going to do is we're going to look at what's our prop band. And how I like to determine prop band is I like to look at the probable range of the error. So if I have a zone temp, and I know typically that my probable range of my error could be 30 or could be 15. This could be somewhere between 30 or 15. So let's choose 20. So my prop band right off the bat for a zone temp would be 20. And then I want this, I usually set my I at somewhere between 0.1 to 0.5. And then what you're going to do is you're going to go and put your VAV box into hand. And then you are going to manually set the set point 2 degrees or 4 degrees lower than the input. So if I have an input of 70, I might set the set point to, or higher, set point to 74. That's going to introduce a 4 degree error, which 4 times 20, I should get 80% valve command. And then right there, we're going to know that we have 0.1 of I. So after 60 seconds, we should go and have 86%. So after a minute, after 2 minutes, we should have 92. After 3 minutes, we should have 98. Do you guys see how I did that? Does that make sense? Give me a thumbs up if that's making sense. Let me know if you have any thoughts. But is all of this making sense? Are you feeling comfortable? If you were to watch this, let me ask Mike. Mike, you say you're an 8 with PID loops. So if you thought back when you were a 2 with PID loops, would this have made sense to you? Or do I need to go more basic than this? Give me some feedback here. Let me know. And I'm going to wait a second. Because based on how you guys answer, I might even unpack this a little bit more. But if this is good, if you guys are feeling this is comfortable, then I'm going to leave it here. Because I think this PID loop has been beaten to death. 1 second. What? I'm on live stream. 8-year-olds don't listen, do they? Go to your room right now. Thank you. I am watching the kids tonight. Yes. All right. Awesome, Mike. So, yes, this is how a PID loop works. this is how you can tune a PID loop. And then basically over your career, what's going to happen is you're going to start to find that certain prop bands, like this 20 prop band, works well for VAV boxes. And you're going to realize that certain prop bands don't work well for VAV or for pressure, which may be much more sensitive. So you don't want to shoot your output so high. So you may say that for a pressure that you have a 5-point band because you want this output to increase very slowly. And then you may weigh your eye a little heavier. But basically, you're going to come out with your own index where you're going to say, all right, for VAV boxes, I do this. For chillers, I do that. For pressure loops, I do that. And the reason I'm hesitant to give you values is because each control manufacturer goes and does this differently. For example, before I worked for Johnson Controls, I used to work for Allerton. And Allerton would have a STUP value, a startup value, that you could always make sure the output went to a certain value. It had iLim and iMax. So you could actually put a limit on your eye. And then, working for Johnson Controls, they take a lot of that and automate it for you in their controls. And that's neither good nor bad. You know me, I'm pretty vendor agnostic, so I'm not steering you any particular way. It's just you need to be cognizant that, automated logic, they also do it a little bit differently. Everyone does their PID loops and the inputs and outputs they have a little bit differently. So you got to be cautious when someone tells you, oh, you got to use this for your prop band or this for your eye. That may not be specific to your vendor. Alrighty. Yeah, definitely. There are some Excel PID spreadsheets you can look at. Mike, if you wouldn't mind linking some of those to the group, that would be pretty awesome. Honestly, I went and tried to Google some of them because I'm so used to using just PID tuning on actual equipment. And all I could find was stuff that was for like rocket science. And I was thinking, yeah, I'm pretty sure no one in this group is going and tuning jet turbines. And if you are, great. I think you're probably in the wrong group, but hey, welcome. Have fun. So, all right. If I keep looking to the left, it's because my comments are over on the left. Can I speak to the auto tune in JCI? Yeah, sure. So in the Johnson Controls controllers, they have what is called the controller configuration tool. And if you notice hesitancy in my voice whenever I talk about another controls company or even my own, it's because I try to walk this delicate line. I don't want to damage my credibility by anyone thinking that I'm sponsoring any particular control system. I've been doing this for a couple years now, and I think I've done a pretty damn good job of being vendor agnostic. Heck, one of my most popular posts is "What is tritium?" And that's kind of like blasphemy for being from Johnson Controls. But in all seriousness, so I'm talking about the BACnet product line, the controller configuration tool. Sorry, I've got allergies, so I keep scratching my nose. But the controller configuration tool has a PID loop in it, and it has a bunch of different inputs, but essentially what it has is a time constant. And you set that time constant to a certain value, and based on where you set that time constant and the prop band, the loop is actually going to start self-tuning itself. Those are only the starting values. And then the loop actually has some logic inside it that it's some proprietary logic. I don't even really know because it's actually inside the firmware itself. So I couldn't see it if I wanted to. But it essentially learns how the loop is reacting and then adjusts those settings. So they give you some settings that they recommend you use. And then the PID loop automatically adjusts itself. And then it goes and adjusts the output based on that. That's how it works in a nutshell. Versus the Allerton one, At least last time I worked on it back in 2010, it was all you go set it manually. Um, Neither one is necessarily better than the other. It just depends on really what you want to do. If you want to have more manual control versus kind of that set and forget control, it just depends like what you're trying to achieve. Awesome. Thanks, Mike. Did that answer your question, Rob? Hopefully it did. Are we feeling comfortable on PID loops? If so, I recorded a podcast for sequencers. And I am not going to go into that teaching today. But what I am going to go into is I am going to look at Rob's question here that he asked a second ago. And he said, have I done anything with pulling in weather conditions into the BAS, and how could it be accomplished? Yes, I have. I have done a lot with weather stations, and I will show you exactly how it can be accomplished. So, with that being said, let's talk about APIs. Eyes. that was my lame attempt at an echo. All right, so APIs, application programming interfaces. Essentially, you have a NOAA weather station, which stands for some four-letter government acronym that I could Google, but I don't know off the top of my head. I think Einstein said, why would you memorize something that you can look up in a book in 5 seconds? Yeah, why would I memorize something I can Google in 5 seconds? But essentially, NOAA has an API, and this API shares weather station geolocated based on your zip code, mine being 53105. And I would go and I would put in that zip code, and it would give me a URL. And essentially what that would look like is something like this. Oh, NOAA weather station API. All right, there you go. So here you go. It would give me the API right here. And then what I would do is I would go grab this data, right? I would do my little request, and my request would then come back into an XML format, which is extensible markup language. Let me see if I can... Oh, look, there it is right here. And this little document right here is going to tell you exactly how you're going to pull the data. And so this is what you're concerned with right here, location. So it's going to give me my location, my point, my element, my attribute, all this fun jazz, right? And so basically what I do is I go in here and I say, I write a function called get weather with an int called zip. Okay? And this is going to be some pseudocode. And it's going to say, it's going to be a filler URL. Well, URL equals NOAA plus zip. And basically what I'm doing is I've declared a string called NOAA, and that string of data equals like http :// NOAA.gov / API question zip equals. And basically what I do here is, since I've declared this string, I pass this string through, right? And this maybe will return response. And that response may be a JSON object. So maybe I declare JSON response equals blank. Okay? Is this making sense so far? And then I get the weather. I get the response from there. And then I take this response and I basically crawl through it. And I go and I would grab... maybe I do like 4x. I'm coding on the fly. I barely remember this. X equals response length. X plus. And basically what I'm doing is I'm going to go and crawl through this response and I'm going to look for temp and humidity. And when I find them, I'm going to send them to some ints. No. I'd want to use some doubles. Double temp, double humidity equals, and it's much deeper than this, but this is really basic high-level pseudocode. But are you following? You guys, give me a thumbs up. This makes sense. Basically, what I do is I define a JSON object, or actually, in this case, it would be an XML object. It would not be a JSON object. So I define an XML response. I do a string for, call it Noah. I would define the URL. I would add the zip that I want. I would then get a response in XML format. And then I would do a for loop to go through the response and pull out any temp and humidity points and send them to some points I already created. Rob, that was probably... I don't know if that was deeper than you wanted me to go, but essentially all you have to do is you have to find the API. You have to get what's called an API key so you can authenticate with the API. And then you have to write a little JavaScript code. And then once you have these points, depending on if you have Tridium or you have Johnson Controls or whoever you have, each one of them has their own little API, and you would just have to pass those into some points on the system. Hopefully that makes sense. Let me know. What other questions do you all have tonight? Let me click back here to transition. Here we go. Hopefully that was... Yeah, so then if you want to bring it into Metasys, then what you're going to do is you're going to use... Let me teach you all a trick here. This is a trick that's independent of Metasys. Okay? So whoever you want to tie into, in this case we're going to say Johnson Controls API. Oh, look, there. Right there. First thing. Right here. So if it's Johnson Controls, then you're going to want to use the write property web method. So what you would do is you would get the MSSDA, which talks through this, and I'm not going to go super duper deep into this, but essentially you would get this document, and this document's freely available on the web. You would then write an application using this. You would then get the fully qualified reference. You would write that kind of pseudocode that I just showed you. And then you would have that pseudocode sample the weather station every 60 seconds. And then every 60 seconds, it would write that zone temperature sensor or set point using the come on. Write property method. And it says, here's your input. You're going to have to put the reference, which is the name of the point, the property you want to write, the new value you want to write. And then remember, this is a BACnet object, so you're going to have to say the priority. And then your output is going to get a status. You're going to get an OK status. And the status value is also going to give you a return of an int 32. Does that make sense? I know I'm talking about it like it's super easy. Like, oh, yeah, you just do the right property. And there you go. I can understand it can be a little complicated if you haven't done this before, but this is essentially how all of the control systems APIs work. They all basically work the same. Tritium is in Java, which Java sucks. Sorry if you're a Java developer out there, but you guys chose a crappy language. I'm just saying C# is where all the cool kids are at. But that's neither here nor there. Anyways, so that being said, Tritium uses Java. This is a DLL, so it's best used in .NET, but .NET's a Microsoft language. Hopefully that made sense. Yeah. Yeah, I mean, you saw me. I just typed in Johnson Controls API. Boom, done. I mean, you need the credentials to authenticate with the engine first. So, you've got to do some authentication. And this is a single-threaded application, so you're only going to be able to run it on one thread. But other than that, pretty basic, right? So there we go. And, Tritium, the same thing. Their SDK is a little bit harder to find. They keep it a little buried. Yeah, you could do that with Allerton. You can do a couple different ways. Also, another really cool trick I like to do with folks who are not friendly in sharing their APIs is this guy right here. Let me show you. Yet another BACnet Explorer. It's a really nice C# application that you can get the source code. And he has a sample BACnet client and server. And so essentially you can create your own BACnet server and go and have a function that then writes from a web service to a point on that BACnet server. And then you can discover that server and pull it into your Allerton system. This is a pretty cool way to do things. I don't think it's at all what the maker of this software intended you to use it for, but it's open source software, and it works pretty nicely to do that. So I would recommend that you can do that, and it's something I've had great success with. So that is yet another BACnet Explorer right here. Also, what it's also really cool for is if you can get on a local network and you do a BACnet scan and they haven't implemented BACnet security, which most folks haven't, you'll discover all the BACnet devices. And then you can do cool things like change the name of the device or change point status and all sorts of cool stuff that you're not supposed to be able to do. Go security! So, anyways. All right. So with that being said, any more questions? Anytime, man. That's what we're here for. I really do love teaching, and this is awesome. I wish I could do it full time. One day, someday, I keep working towards it. I'll get there. Slow and steady. That being said, what else? Any more questions before I show you guys the most awesome thing that I found on the internet this week? I'm hyping it up. It's going to be ridiculously cool. And honestly, I'll be transparent with you guys. I plan on creating a course on teaching IT to building automation professionals. And honestly, I had a greedy moment. At first, I was like, you know what? Should I show them this? Because I want to teach a building automation IT course. And this basically it's an IT course. It's not focused on building automation, but it's an IT course. It's a really damn good IT course. And I was like, yeah, but I want to teach folks a building automation IT course. And my greedy side was like, yeah, let's just do that. But my altruistic, I really do want to help people side won out. And so without further ado, if you haven't seen this before, the Microsoft Network Fundamentals course. Absolutely free, 8 hours of IT teaching goodness. And this is high quality stuff. Really good. Goes through understanding local area networks, defining the OSI model, which is always good to know. That's very useful. Understanding wired and wireless networks, IP protocol, TCP/IP, networking services, DHCP, IPsec, remote desktop, wide area networks, routing, some basic network security stuff, zones and LANs, and then other resources that they recommend. So guys, I was talking to a coworker today and they were saying, yeah, I'm going to go spend $1,000 on a IT course. And I was like, what for? And they're like, well, I want to learn the basics of building automation. And I said, really? Or they said IT. I want to learn the basics of IT. And I said, really? And I'm saying, how much are you going to pay for that? They're like, oh, I'm going to pay $2,000. I got to fly somewhere. Da, 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 da. I was like, well, you could do that. Or you could go watch this course that I found on Microsoft and in about 6 hours probably learn the exact same thing for free. And they're like, oh, really? It's like, yeah. So here you guys go. This is your early Christmas present. Have fun with it. It's going to be I've been through it. I wouldn't recommend it if I hadn't been through it. It's a pretty good course. All right, question. Do I recommend using this API as your outdoor air temp in a building that systems are dependent on it, or only as a dashboard type application? So that is a tough question. So here's what I recommend. So you've got resets for your hot water system. You've got other values that are dependent on outdoor air temp. And you're like, I want to do this API thing, but I'm not sure if I really want to go and worry about a network failure. And so here's what I recommend you do. You have a outdoor air temp that's hardwired, one outdoor air temp. And you put that in a reasonable spot in the building. But what you can also do is you can have this other outdoor air temp that's coming from the API. And you can use that API outdoor air temp along with the humidity. And that outdoor air temp can be whichever ones you're more accurate. The reality is most of the ones I see stuck on a building, one, they drift. So you lose a couple degrees in accuracy. Two, they tend to be put in really crappy locations. I showed this one picture, I think, of this outdoor air temp sticking out of a drainage pipe on the ground by a building, on the north side of the building. So yeah, that's a great place to put it. So that's what I recommend. Use the API normally, but you have the fallback in case you need it. And that's some simple code. You just look, and if you get an unreliable signal, you have a switch that says, if it's Boolean logic, it'd be like this, right? So let me draw this logic for you here. Let me switch. Okay. So you basically do this right here, right? You'd say, all right, get your OR gate. Oh my gosh, can't draw. Hold on. Here's your and. So outdoor air temp equals unreliable. And you could do that. You could do your OR gate, not your AND gate, is what I meant to say. That's an OR gate. Then that goes into your switch, which then is going to have an output. And this is going to be that same outdoor air temp is going to be going here. And then this outdoor air temp is going to be your building. So you can map this to either of the ORs. Or you could just put it to an OR and you could have this one be mapped to a Boolean false. And then if this one trips, if this outdoor air goes unreliable, the switch is made and you get building outdoor air temp. That's some basic logic right there. Ho, ho, ho. All right. So, there we go. What other questions do we have? What else can I help you all with tonight? I love this stuff. This is great. This actually is going to be my tip of the day. I'm going to use this for a tip of the day. I think this will be good. So if there's no more questions, I'm going to go and say, for all of you out there, thanks for watching. I encourage you to comment in the Facebook group. If you're not in the Facebook group and you're watching this on YouTube, I encourage you to join the Facebook group at facebook.com/groups/Building Automation Monthly, or Building Automation Monthly, not .com. And I also encourage those of you watching this on YouTube to join the Building Automation Monthly community at buildingautomationmonthly.com. I really encourage you to take advantage of this free teaching. I mean, seriously, folks, if I was charging for this, this would be several $100s an hour that I would charge for my time. Because, I mean, guys, I've worked on some of the most complex stuff out there. Stuff that is really crazy. And I've got a lot of experience. I don't say that to brag. I just say it that I've done a lot of stuff. And I want to share all that with you all. I have fun doing that. So take advantage of it. So with that being said, unless there's other questions, I'm going to call it a night. Alrighty. I will see y'all next week. And by the way, ask your questions in the group. Got a lot of smart people in here. Take advantage of it.